everybody, my name is Professor Lines and Valley, and welcome to another lecture of physics. Wow! We took a long time to set this up. So, thank you everybody for coming to Physics 141. We're actually doing this digitally instead of on a whiteboard. So today, we're going to be looking at the constructive and destructive interferences. First, you may be asking, what is the constructive and destructive interferences, Zamorno? What kind of crap are you talking? Well, not talking any crap. First, let me tell you the waves are not only everywhere, like in radios, in your light bulbs, in the ocean, and right now going on in your body. There's all sorts of waves. And if waves didn't exist, we would be blind. We wouldn't be able to hear anything because of no sound waves. And we would probably die because, our heart depends on a wave too. So, there's a lot of things that depend on waves. Some of them are even vital. So, you shouldn't ignore waves. Sometimes they can even help us look into our future. So that's why this is a pretty important subject. Oh yeah, now I have a live broadcasting of myself from side view and not from digital view, obviously. So, constructive and destructive. So, we're going to be looking at constructive and destructive interference. Now, what is constructive interference? Well, constructive interference is when two waves go together. What do you mean two waves go together? Do you mean two waves that literally wed with each other? I don't know. I don't know what kind of crap you're thinking, but that is not what constructive interference is. When two waves come together, I don't literally mean by, marrying or other things like that. Really mean just, meeting together. How do I say this? They are in sync with each other. They meet up at every single point. So, let's say we have one wave source. This wave I'm going to send out is going to be blue. And then we have the second wave source. And I'm going to make it also, and I'm going to make it the same path but a different color. So now, if I select a 2 and put it on top of 1, so put it right on top of 1, you can sort of see that they come together. They are in sync with each other. I'm not the best drawer, so this didn't really work out for me. So let's see. Yeah, that looks better. So yeah, you can see that they meet at every single point. And you can see that really the valley or the crest meet up together and the troughs meet up together. So you can see that they're in sync. They're completely in sync. Now, let's say I move this half a cycle ahead of 1. So this is regular. I'm trying my best to make it look regular. And then we move it like this. Then suddenly things change. Because now we see that the crests line up with the troughs, and the troughs line up with the crests. So now that is out of sync things. So now I'm going to make some new things. Okay, there were things like this over here, and then select that, and then you want a copy of that, want it pasted, and then I'm just going to take a new model of that. I think that looks better. So now I'm going to delete the original. So that's going to look like this. Delete, and we put the new one down here. And this thing is okay, going to be 2. So now, let's see what happens if we line these up with each other just for a better picture. You can see that basically the crests and troughs line up together. Now, let's see what happens if we move it ahead. Now, you can see that the troughs and crests line up together, and the crests and troughs no longer meet. So this is where we were at. However, if I just move it a little again, it gives us something that's constructive. The crests line up with the crest, the troughs line up with the troughs, everything is back to normal. So, that's a very interesting topic. Now we have constructive, lengths at which some things are constructive, and lengths at which some things are destructive. So, constructive lengths would be, well, let's see what these would be. Actually, I'm going to do that. Sorry. So now, if we have this and move it onto here, if we map it onto here, we can see 0 wavelengths in that they are already constructive. So now, let's see where we're constructive again. So let's put this, select this, and we're going to move it there. That's destructive. We need constructive. Thank you. Okay. So now we have constructive again. And let's see. The front moved from here up to here. So moved this much. So to delete this, you can actually see that it moved 1 wavelength to be able to be constructive again. So just going to bring it back. So now, if you do it again, can see that this pattern repeats. Basically, it's all the positive integer lambdas, or wavelengths. Now, let's see how destructive interference is. What wavelengths destructive interference persists in. Keep in mind, we're assuming that these are the same wavelengths. There are different things that might happen when you have different wavelengths. We'll cover that in another video. That's where we're constructive, and we get destructive over here, and we see that the front has moved from here to here. Now, if you erase this box, you can actually see that just about half a wavelength, meaning that it takes half a wavelength for this thing to, for the first destructive part. Now, as you would expect, if you brought it back here and got destructive again, here this is our first one, then you would want more destructiveness. Maybe move it a little there. Alright. So now we know that it's moved. And last time was here. It last time moved from here to here. Now, I think I skipped something. No, I did not. Because this is one full cycle right over here. That's one whole lambda in the half. So, that means you add 1 to it each time. So, blah, blah, blah. So, that's what it looks like. However, some of you may wonder what it looks like when they're not in sync the first time around. Well, what happens there is you just switch most of the stuff around. See this? Take this here. This. Take this here. Yep, that's destructive now. And this stuff is going to be constructive, or out of phase things. So, pi-shifted things that are half a phase ahead or behind are, so this is for a pi-shifted phase. Pi-shifted is because one whole circle in radians, or a whole cycle, is 2 pi. So half that would be just pi. So now, thank you everybody for watching, and I'll see you next time. I'm going to zoom in on the married wave, because why not?